Okay. Lesson 8.5 is where we're going today. Hopefully, you guys are pros on simplifying, multiplying, and dividing rational expressions. Okay? There was a lot of factoring, a lot of canceling, right? Okay, so today, we're still working with rational expressions, except now we have to add and subtract. Okay, so we're adding and subtracting fractions. That's the short of it. Okay, the deal is that we're adding and subtracting fractions similar to what you were working with yesterday. Okay, maybe not quite as ugly as yesterday, but you know, you're working with these same type fractions. So, back to basic middle school, maybe even elementary. To add and subtract fractions, what must be true? Have to have that common denominator. And that will be the name of the game today. That's the trick, is you have to get that common denominator. So it's still going to be we're still going to do a lot of factoring, okay, unless it's already factored for us. So there's still going to be a lot of factoring. And so the example here, and I'm not going to really spend a lot of time on this, but if you are asked to add 4 over x squared plus 3x plus x minus 2 over x squared plus 6x plus 9. Notice, are those denominators the same? No, they're not the same at all, are they? And just like last time, no, we can't say, oh, but they have an x squared in common. We just have to add 3x, add 9, we're good. No, it's about the factoring again. And so notice the first thing they do here is they factor. X squared plus 3x, there's a GCF of x. And so factors to x, x plus 3. X squared plus 6x plus 9 factors into x plus 3, x plus 3. Once we have pieces factored, we'll be looking for what's in common. Okay? And so like in this case, as you look at those two denominators, they already have one x plus 3 in common, yes? So that one x plus 3 that's in common would be part of my common denominator. There's also an x here. So guess what? This x has to be part of my common denominator. Over here, there's a second x plus 3. And so you have to use the second x plus 3 as well. So common denominator, we're first going to look at what's in common, what overlaps, and take those. And then we're going to look at any leftover pieces to find our least common denominator. Okay? So let's look at example 1, or example 1a, excuse me. What is the sum of each of the following in the simplest form? Notice it's still asking for these lovely restrictions on the variable, right? Which that part has not changed. Okay, we'll still do that the same. So, okay, we need to add x plus 1 over x minus 1 plus negative 2 over x squared minus x. Okay, to add these fractions, what's the first question to yourself? Yeah, do they have a common denominator first off? Unfortunately, no. I do feel like in homework maybe your first one has a common denominator. I can't remember. I feel like, but the thing is, it's nice, but yet you guys aren't expecting it, so it's almost confusing, you know. So do beware, you might have some in homework that already have a common denominator. Scary thought, but it is possible. Okay, so now, as we look at common denominator, the first thing I always want you to do with these denominators is to factor them. Always get them factored. As we look at x minus 1, well, what do you know about x minus 1? It's x minus 1. Okay, there's no product sum, there's no GCF, it's x minus 1. What about x squared minus x? What do you notice about both of these terms? They have a GCF of an x. So I'm going to come right below here. I'm going to factor an x out. If I factor an x out, x squared divided by x leaves me with x minus x divided by x is a 1. So instead of thinking of this denominator as x squared minus x, I'm going to think of that denominator as x minus 1. So now, we have to work towards a common denominator. What do my denominators already have in common? This fraction and this fraction has an x minus 1 in common, correct? So that means x minus 1 is part of my common denominator because it's already there in common. Anything else in common? No. Okay. Are there any leftovers that we haven't used yet? Yeah, what's the leftover that wasn't in common that we haven't used yet? An x. So what also has to go in my common denominator? X. So as I write this out, and I'm going to rewrite this with our common denominator. My common denominator is first of all going to have the x minus 1 that's already in common, and it's going to have the extra x. So I want to make this happen so that both fractions have the common denominator of x times x minus 1. Are we okay with me saying that that's the common denominator? You understand why I picked that common denominator? X minus 1 was in common. The other single x was the leftover x. Now, as we look at the first fraction, the original first fraction has a denominator of x minus 1. I need it to have the denominator x minus 1. So what is it missing from the common denominator? It's missing an x. So that means we need to take this and multiply by an x. What you do to a denominator? You do to the numerator. So if I'm going to multiply the denominator of this problem by x, that means I'm multiplying the numerator by x. And so that means on top, I'm going to have x times x plus 1. And I'm kind of doing this in baby steps this time through. Okay, well, I'll do that. I'll do it in baby steps a lot. If you want to go ahead and multiply that top, you can. Or you can wait and do it on the next step with me. Second fraction. What was my original denominator was x squared minus x, right? Factored, it was x minus 1. What's my common denominator? X minus 1. Did my denominator change any? No. So does my numerator change any? No. It's still going to be negative 2. Okay. Once you have a common denominator, how do we add fractions? Yeah, you keep the common denominator, right? And you add the numerators. So meaning, okay, let me write one fraction. What's the denominator of this fraction going to be? X minus 1, because we keep the common denominator, right? Does it help? Do I need to go back and ask you a basic, okay? How would I do 4 sevens plus 2 sevens? You would keep the 7 and do what? 4 plus 2. You guys are all saying just 6 sevens, Miss Sargent. 6 sevens, right? Yeah. But do you see where I'm going? Do you see why I'm saying this? How did you get that 6? You added 4 plus 2. You kept the denominator 7, and you added 4 plus 2. That's what I need you to understand. No.
You can't minus the 2 from the...
Okay. So, we're going to add x plus 1 plus the negative 2. Now, at some point, now or later, I would encourage you to distribute the numerator. The denominator, I'm not going to multiply.
Yes.
But the numerator, I am going to multiply because we might be able to cancel something later. So, x times x squared, plus x times 1, 1x or x. So that's my first numerator, right? That is x squared plus x, plus negative 2, which means I'm just going to write minus 2. Pausing for a moment. Are you guys okay with what I wrote down there? Now, it's a 50-50 shot. We might be done right now. You might be able to type this into Math Excel, and it might work for an answer. There's also a chance that that top will factor, and if that top factors, there's a chance something could cancel. There's also a chance that we factor that top and still nothing cancels. But here's this, what I'm going to encourage is that you need to factor that top to check. Maybe nothing ends up factoring, but at least you know. Okay? So, does x squared plus x minus 2 factor?
Yes.
Can I come up with, so you're telling me you can come up with two numbers that multiply to be negative 2 and add to be 1?
2 and 1.
2 and 1. What about a sign?
Negative 2.
Positive 2, negative 1. So it does factor, yes? Okay, let's write that down. X squared, x and x. We said 2 and 1, a plus 2 and a minus 1. Denominator carries along. X minus 1. Was it worthy of our time to factor that?
Yeah.
It was. Had you entered the previous answer in Math Excel, you would have gotten it wrong. Well, you probably would have gotten although this is equivalent to a correct answer, it is not in simplest form, or however they give you that big long answer. But basically they're saying equivalent, but not simplified. So, cancel our x minus 1s, just like yesterday. And we now have x plus 2 over x. Can I cancel those x's?
Yeah, I don't
think so. Because
know
X
because it's married to the 2.
X is married to 2.
Oh, I knew
So
it.
no. Okay.
Just to get X
It's-
to a divorce lawyer.
Okay, it's x plus 2. Now, if this was x times 2, we could do it. But since it's x plus 2, we can't.
Oh, no,
So-
the relationship's looking pretty strong. It's positive. They're doing positive things.
Okay, so final answer, x plus 2 over x.
Oh, it's X is still.
Now, the one other thing they did ask us to do is restrictions on the variable. This part has not changed from yesterday. How do we find any restrictions on the variable? Denominators equal to 0. I would always use the factored form. And where am I going to put this? I'll just squeeze it in right here. Basically, look at your common denominator. What did we have as factors? An x and an x minus 1. So if we set x equal to 0 and x minus 1 equal to 0, what are my restrictions on the variable? X cannot equal 1 and 0. Okay. You ready to try B?
Yeah.
B is x over x squared minus 4 plus 1 over x plus 2. So do my fractions have a common denominator? Not currently, which means we have to make that happen. Before we get a common denominator, what do we need to do with our denominators?
we gonna change the x squared minus 4 or something?
Yeah, we need to factor them. Get them in factored form. Does x squared minus 4 factor?
Yeah.
And your answer should be yes. X squared minus 4 factors into 2 parentheses, x and x, a minus 2 and a positive 2. What about the second denominator? Does x plus 2 factor?
No, just.
I'm just trying to get you to ask those questions to yourself, though, right? Like, always check all denominators. Okay. So, thoughts on what my common denominator is going to be? What do the fractions have in common? They have an x plus 2 in common. So, x plus 2 is part of my common denominator, right? Now, that takes care of that fraction, right? And it takes care of this x plus 2. What leftovers do we have? X minus 2. So what's my common denominator? X plus 2, x minus 2. So I'm taking a step where I'm rewriting out both fractions with that common denominator. What do you know about the first fraction? It stays x, doesn't it? We already have the common denominator here, don't we? Since we already have the common denominator, we just carry the x down in the numerator. It does not change. What about x plus 2? What about the second fraction? Yeah. Here, it was x plus 2. Down here, it's x plus 2, x minus 2. So I need to multiply by x minus 2. What I do to the denominator? We do to the numerator. Okay. Don't overthink this. What is 1 times x minus 2? Because 1 times anything is just anything, right? So 1 times x minus 2 is x minus 2. Okay, do we have our common denominators now? Now we're ready to not eliminate. We want to, but add the two fractions together. What's the denominator on these two fractions? Or what's the denominator on my answer? X plus 2, x minus 2. I've already got that common denominator, right? And what do I do with the numerators? You add them. So I'm doing x plus x minus 2. What is x plus x minus 2? Not x squared. 2x minus 2. Because what's 1x plus 1x? 2x. And then we have a minus 2 tagging along for the ride. Not exactly. Okay, so that numerator is a 2x minus 2. I can't separate. It's not a 2 times x minus 2. So if you're going to cancel the x minus 2, it would have to be like 2 times the quantity. So like x minus 2 would have to be in parentheses. Okay? I know. If we want to cancel so bad, right? I get it. Now, can that top factor? Officially, what do we notice about both terms on the top? They have a 2 in common. So let's factor out a GCF of 2 and see what happens. If I factor out a GCF of 2, there's a 2 out front, yes. 2x divided by 2 leaves me with x minus 2 divided by 2 leaves me with 1. I still have x plus 2 over x minus 2. Can I cancel anything? No. This would be the spot, if they were both x minus 2s, we could cancel. Because that 2 is 2 times x minus 1. This would be the spot they could cancel. But in this case, I don't have any common factors. I would say at this point, the opinion would be, because nothing canceled, you could have also left your answer like this. The question is, does Math Excel share that opinion? Maybe. I'm not going to guarantee it. Okay? So, you could leave your answer either way. I would be fine with either. Math Excel may or may not like the unfactored version. Okay. Restrictions on the variables. What are my restrictions? Positive and negative 2. Because if you set x plus 2 equal to 0, x minus 2 equal to 0, x cannot equal plus or minus 2. Okay, my plan was to skip C and go to example 2A. What's different down there about example 2? We're subtracting instead of adding. Does that change a whole lot? It doesn't change a whole lot. You just have to be careful that you are subtracting everything in the second fraction. That's the only key. Okay? So, let's go ahead and talk common denominator for a moment. I know we're not going to get through all of this as much as I'd like, but before you can find common denominator, what do I have you guys doing? I'm going to tell you factor. So, does x squared minus 2x factor? Yes, both terms have a what in common? An x. So there's a GCF of x here. When you factor out an x squared. What about my second denominator, 2x minus 4? GCF again, this time my GCF is 2. So if I factor out a 2, divide both those by 2, I have x minus 2. Thoughts on that common denominator? Ask yourself what's in common, which is x minus 2. And ask yourself, what are any leftover pieces? X and 2. So, x minus 2 times an x times a 2. Well, what x times 2, how do we usually say x times 2? 2x times x minus 2. So when I write this as a common denominator, I would write 2x times x minus 2. And that is where I will have to pick up tomorrow. Okay. Homework will be available for lesson 8.5, or it should be. You can start it not sure you're going to want to finish it yet. Okay. My plan is to do maybe A and B in the subtraction tomorrow, and then we probably need to talk about simplifying complex fractions on the top or on the back. So maybe like A and B from the back. So maybe some work time tomorrow. I feel like I'm running a little bit behind where I really wanted to be today, but we'll make it work.